Welcome to this video on Year 1 Pure Chapter 3 Prep Practice Test Answers. So question 1 is to solve simultaneous equations. Now there are several ways to solve simultaneous equations, and the way I'm solving these, because they're linear, is to simply take a multiple of one equation and a multiple of another equation and then adding and subtracting them according to whether the coefficients are the same and the same sign or the same and different signs. So here I'm going to take twice equation 1 to get 6x plus 8y equals 12. And then we can see that we have the number of y's is the same in equation 3 and equation 2, except that the 8y is negative in equation 2 and positive in equation 3. So if we now add equations 2 and 3, the minus 8y and the plus 8y give us 0y, the x and 6x give us 7x, and the 9 and the 12 gives 21. So 7x is 21, so x is 3. And now going back to equation 1, 3 times x, which is 3, is 9, plus 4y is 6. So that means that 4y equals minus 3, so y equals minus 3/4. Now we could have done equation 1 another way, which is to use substitution, and that means that we get either x or y from either of the two equations and substitute into the other equation, and it should give us exactly the same answers. But in question 2, it isn't easy to use the first method, systematic elimination. So here we push down the substitution method. So looking at both equations, I'm not going to use equation 1 because that looks too complicated. There are x's in more than one place with an x squared and a y squared and a y around the place. So it's going to be easier to use equation 2. And in equation 2, I can get a y in terms of x or x in terms of y. But because I'm being asked to get a quadratic in y, that means I'm getting rid of the x's. I'm going to make x the subject. So from equation 2, adding 3y to both sides, I get that x equals 3y plus 6. And now in equation 1, wherever I see x, I can replace x by 3y plus 6. In other words, I'm substituting out the value of x by what it's equal to from the other equation. And so I get 3y plus 6 squared plus 9y squared plus 3 x becomes 3y plus 6 times y equals 12. And multiplying out carefully, remembering that 3y squared gives us 9y squared because 3y times 3y. I'm going to get 2 times 3y times 6, which is 36y. I'm going to get 6 times 6, which is 36. And then multiplying out the rest, I get this quadratic. Tidying up, we get 27y squared plus 54y plus 24 equals 0. And now dividing by 3, we get 9y squared plus 18y plus 8 equals 0, which is simpler to solve. And then for part B, I'm going to factorize, although of course I could complete the square or use a formula. And I get that 3y plus 4 is 0, or 3y plus 2 is 0, which means that rearranging 3y plus 4, I get y equals minus 4/3, or rearranging 3y plus 2 is 0, I get y equals minus 2/3. And then putting in each of these values into the equation x equals 3y plus 6, for example, which is the easiest, I get y being, so I get x being 2 and x being 4. But be careful, you need to give the pairs. So when x is 2, y is minus 4/3. When y is minus 2/3, x is 4. So we mustn't combine an x of 2 with a y of minus 2/3 or the other way around. So the pairs need to be given. Equation 3, we have simultaneous equations. Now for linear equations, you can just manipulate linear equations, inequalities, like linear equations. So we can multiply or divide by a positive, we can add or subtract anything, but if we multiply or divide by a negative, we have to reverse the inequality. So multiplying out the first inequality, we get 3x minus 6 is less than x minus 4, and now subtracting x from both sides and adding 6 to both sides, I get 2x is less than 2, which means that x is less than 1. And we can represent this diagrammatically with a 1 not wanted and all the values below it wanted. So these are the values strictly less than 1. So in other words, any real number up to but not including 1. Likewise with the second inequality, we have 5x minus 1 is greater than or equal to 2x plus 5. Multiplying out, we get 5x minus 5 is greater than or equal to 2x plus 10. And then rearranging, we get 3x is greater than or equal to 15, which means that x is greater than or equal to 5. And this time it's greater than or equal to, and so we include 5 and any value is greater than it. But if we want to solve these two equations simultaneously, a value of x has to be strictly less than 1 and 5 or more? Well, that's impossible because these two intervals don't overlap. And so actually, although there are solutions to the first equation and the solutions to the second equation, there are no solutions to the simultaneous equations. Had it been, for example, this number here had been, let's say, 6, and any value less than 6, and any value of 5 or more had been wanted, then the overlap would have been values between 5 and 6, including 5 but not including 6. But in this case, there is no overlap in these two intervals, and so there are no solutions. So a good way of representing your inequalities is to use these arrows and circles, either left blank or filled in, to help to understand what solutions we have, if any. Question 4, we have a quadratic inequality. Now be careful with quadratic inequalities because people often make a mistake and try to do them in the same way as linear inequalities. And if you test your values that you get, you'll find that often you get values that don't work. So let's see how to do it. So there are a couple of methods, but in both methods, the first thing to do is to find out when the quadratic equals 0. So rearranging quadratic until we have 0 on one side. So we want to know when this quadratic is less than 0. So let's look at when it equals 0. Well, by factorizing, we can see that it factorizes to x minus 3x plus 1. So this quadratic equals 0 at -1 and at 3. And now we want to know, is this inequality true for values of x between -1 and 3 or outside of -1 and 3? And there are two ways of doing it. One is to sketch. So we call the expression that we want to be negative, the x squared minus 2x minus 3, want it to be less than 0. We call that y. And by drawing this curve, because we've done in chapter 2 drawing quadratics, we know it's going to be smiley and we know it's going to go through -1 and 3. And so now if we look at this curve and ask ourselves, when is the y coordinate less than 0? Well, if I take a value like 4, which is greater than 3, we can see that the y coordinate going up is positive. If I take a value like -2 and put an x value of -2 in, we can see the y coordinate will be positive. But for x values, let's say 0 or 1, the y coordinate is negative, and therefore the expression will be less than 0, it will be negative. And so we can see that the solutions of this inequality are all the values between -1 and 3, not including either of them. And we write that as one single interval because there is one interval here bounded by two values, -1 and 3, not including either of the values, so strict inequalities. Okay, question 5, we have another quadratic, minus x squared plus 6x minus 5 less than or equal to 0. Notice it's less than or equal to rather than less than 0. If we factorize this, we get minus brackets x minus 1 brackets x minus 3, or use a quadratic equation, or class Wiz, or whatever method you like of solving a quadratic. We find that the boundary values are 1 when x minus 1 is 0, and 5 when x minus 5 is 0. And if we draw this quadratic, because it has a minus x squared, it's going to be that way up. So if we do it by the drawing method, we see that the parabola is going to be this way up, and we want to know when the y coordinate is less than or equal to 0. We can see between 1 and 5 the y coordinate is positive, so that doesn't do. For values less than 1, the y coordinate is negative. For values greater than 5, the y coordinate is negative. And so we want two intervals, the values less than or equal to 1 or the values greater than or equal to 5. And so those are our solutions. How could we do it otherwise? Well, the other method for question 4 is to simply try some test values. Because for a quadratic inequality, it'll always be the case that the solutions will be between the two roots or outside the two roots. All we need to do is to try some values. So here, for example, if we try x is minus 3 in question 4, we see that putting minus 3 into the inequality, we get minus 3 squared is 9, minus 2 times minus 3 is 6, minus 3 gives us 9 plus 6 is 15, minus 3 is 12. Is that less than 0? No, it isn't. So we can see that minus 3 does not solve this inequality because it's greater than 0. If we then try another value, 0, which is between minus 1 and 3, we see that 0 gives us minus 3, which is less than 0, and so that does solve the inequality. So by trying test values, we can check the sketching method, or in fact, we can use it as an alternative to the sketching method by simply trying test values between the two roots and outside the two roots, seeing which work and which don't work. And likewise for question 5, we can do the same. We can try any value that we like between 1 and 5. We can try any value that we like less than 1. We can try any value greater than 5 and test them. So here I've tried x is 0, which is to the left, and we can see that that is less than or equal to 0, so that works. We can try a value between 1 and 5. I've tried 2. We can see that doesn't work. I can try a value to the right of 5. I've tried 8, and we can see that does work. So we can see that our answers are consistent with these when we try some test values. Use whichever of those methods you like. You might think the sketching is superior because we're sketching after all, and certainly some people like it, but the trying test values is not an inferior method at all. And in fact, in some trickier inequalities, which you might do in further maths, the trying of values, test values, is a really strong method, and it can be used here if you want to. There are other methods, and if you want to hear about them, just ask me. But these two should do really for majority of questions, and most students prefer these two methods. Okay, I hope that was helpful.